Yeah, exactly. So, that's a post hoc fallacy, isn't it? But, yeah, that there's a treatment or a break in the treatment. It could not be either way. It could go the other way too. Oh, I got a treatment, and then I got cured. It might be due to the treatment, but it might have been with any other reason, isn't it? There are all sorts of things in our environment that can be affecting. It could be, oh, well, I was getting more fresh air, but I didn't realise it. Or I started, I changed my diet, or I got more exercise but didn't really realise it, or anything. And we can't necessarily say that just because something comes before something, that it's been the cause of it. Yeah, huge in health. Yeah. Or the negative, like you say, somebody breaking a treatment and then not getting cured. It's not necessarily because they broke the treatment. Yeah. A lot of superstitions work like this. I've got a job interview, so I'm going to bring my grandmother's lucky rabbit's foot. Yes. And put it in my pocket, and I'm going to kind of feel it as I'm talking, because I love my grandma, and that's her good luck charms she's used all her life. She passed it on to me. Wow, I got the job. Wow, must have been. Thanks, Grandma. Thanks, Grandma. Good on you.
Psychologically, she feel confident.
Yeah, right.
Because of the.
That's right. So, is it the rabbit's foot, or is it the increased confidence? Exactly. Yeah. So it can have its effect, but it's ultimately just a psychological effect, isn't it? There's nothing real happening with that rabbit's foot.
And most of the old people, they used to wear that ladybirds or angels in their coat. If they have something special, they would let me wear my ladybird. It's a good luck.
Yeah. I mean, any good luck thing kind of works like this. If we got 10,000 people and they all had a rabbit's foot and they performed better than people who didn't, could we then say, the rabbit's foot is working?
Sometimes they just give up.
Not really. It might be, as Chaucer says, just a confidence thing, isn't it? We'd have to design an experiment somehow, where we got rid of that. If we got Grandma's rabbit's foot, and the real Grandma was very busy making them, she had 10,000 of them, and then we got some, and the argument was there's something in these rabbits' feet that gives us good luck, and then we got some other thing, a lizard's tail, and we gave that to 10,000 people. There was no claim that the lizard's tail brought good luck, but there's the claim the rabbit's foot did. Mix them up, give them to people randomly, and then the rabbit's foot people do a lot better, significantly, statistically. Then we start to think seriously, there's something in this, isn't it? Right? If we had people with the rabbit's foot and people without, and the rabbit's foot people do better, that's not really going to isolate the fact that it's the rabbit's foot that's doing it, because it could be the placebo effect. Remember, as Chaucer says, it could be, I've got a rabbit's foot, I just feel more confident, and they could do better. It give people a similar thing, that there's no claim that this thing really works. And if there's then a difference, then we have to start thinking, there's something in this. We'd have to start putting Grandma's rabbit's foot under the electron microscope and doing other work to find out what that mechanism is. So in other words, can you see this links with anecdotal evidence? 2 or 3 people have a rabbit's foot and they say, I did really well in my exam, or I got the job. It's not a reliable indicator, is it? We've really got to do mass testing and control the variables very carefully and randomise it to be able to then say later, well, yeah, there was a significant difference, or not. This is why anecdotal evidence, it's a small sample size. We need 100, 200, 300, 1,000, whatever, for the sample size. The other problem is we need to be able to replicate the experiment. There was something just last week in Psychology Today, the sort of big psychological magazine, and I sent it to my daughter because she I did psychology and she's doing it as well. And the editor said, there was a meta-study of previous psychological tests. They took a whole lot of previous tests that showed positive results. They tried to replicate them. And only 39% of those tests came out with similar scores. The others showed no result. So even when you get a result and you publish, and you do it very carefully with statistics and so on, you know, it can be just chance, or there could be experimental bias in there or whatever. You know, I really do want to publish, I do want to get positive results, and you know, people unconsciously kind of massage data or cherry pick or whatever. When you replicate, at least in the social sciences, that's not a very high success rate. So again, even in psychological literature, we can't say, okay, it was published in Psychology Today, therefore I'll believe it. There's kind of a 60% chance you can't get the same result. So things are quite unreliable, and as a scientist and a scientific critical thinker, you've got to be looking at even published literature, thinking, what are the chances you could get the same result again if you replicate? Replication is the sort of principle of science, isn't it? Replicate is like copy. So if you do the experiment again. Now what they found was that even within psychology, it was the social science end where the replication rate, the success rate was really low. It was about 20%. When you went to more clinical science, psychological science, you got a better result. So, you know, even within psychology, you get different rates. So, in other words, social psychology has a really low rate of being able to reproduce the same result in another experiment. So there are real limits to science, and I think that's important. There's no, a good thinker, scientific thinker never claims science is going to tell us everything, or that it can discover everything, or it can explain everything. It's important to recognise the inefficiencies of science and the limitation of the scientific method. That's key to scientific thinking. There's no claim in science that we can explain everything. It's just the most efficient method. But it's not very efficient. Look at the result, 39%. It's not very efficient. The human knowledge methods, or methods of getting human knowledge, are pretty low. That's why we have to be skeptical. You know, don't believe published data. At least in the social sciences, there's a 60% chance, 61% chance you couldn't reproduce that result. This is, I mean, to me, it's a really important finding, because it just shows how critical we have to be and how doubtful we have to be, even of the best published literature, at least in the social sciences. Physical sciences, no doubt, you get better scores than that. But again, I don't have the results and the data, and I guess in some physical sciences would probably be better at replication rates than others. Anyway, that's post hoc. Let's do a couple more. Number 24 on the fallacy list, not the conversation, but number 24. Loaded words. Sometimes people try to convince other people, not by, as we know, not by the evidence or the argument, not by the use of sources with good reputation, but just by feeling. And one way of increasing your emotional element is use strong language. That's just such a ridiculous policy. If you do that, it will destroy our whole way of life. You know, it's strong, isn't it?
I'm doing it, you might.
That is that's an immoral and unjust policy that is extremely cruel to the lowest and poorest and weakest members of our society. There's a lot of strong language in that, isn't there? There's other ways I could say that. I'll try and say it in a neutral way. If you adopt that policy, it will probably produce significantly higher levels of inequality. Can you see how that's more objective? It's not using, there's probably about 4 or 5 words there that are fairly neutral. And the other one, there's all these words that are about cruel and unjust and weak. And every one of those sort of hits you, doesn't it? And it's just the emotional. It's saying exactly the same thing. There's no difference in the amount of evidence or logic or, I'm not quoting any source there, it's just the same. But I'm injecting emotion with every third word I'm using. And I'm loading it. It's like loading up a wheelbarrow with feeling. Now you can do the opposite. You can do it really positively as well. You can say, look, if we adopt this policy, it'll make sure that as citizens we're united in this fantastic democracy that we live in Australia. And it will mean that we can build our nation together into the future. It's all that sort of political stuff, isn't it? And everyone gets stirred up and they feel really good. But it's just that selection of particular words that's doing it. And you're almost saying nothing. I mean, when I just said that then, what did I really say? What information did I give you? Almost nothing. So, sometimes you can combine it with information, and there is information in there, but it's just your choice of words that's doing it. Now remember, loaded words depends on that one. Connotation. Remember, not collocation. We've done the work on collocation. Connotation, whether a word is positive, very positive, very, very, very positive, or negative, or quite negative, or very negative, or very, very negative. And English is pretty good at allowing you, because it's got a million words. You pick any one topic. Think yesterday with the activator. You pick a topic, and you've got a range of words, haven't you? You could pick neutral kind of words for the topic. You could pick quite positive words, or you could pick quite negative words, often about the same topic. What your job is as an academic writer, and as a writer, remember with academic writing we should reduce this, and we should have strong credible sources and strong logical argument and evidence, but low here, so really we've got a neutral there as well in the middle. Your sort of responsibility as an academic writer, you've got to indicate some position with positive or negative, but don't go too far above or below the middle range. Otherwise, you're really engaging in simply trying to convince people on the basis of emotion. So that's that one. I'm just picking them in order for a reason. Let me see. Over the page, cum hoc. We can see the word hoc again, which means event. So we had cum hoc, post hoc. Let's do a cum hoc. I'll leave that up so that you can see the difference. Same bit at the end. maybe I'll put a word together with. Cum is related to co, con, com. You know, in English we've talked about that before, these prefixes. What do these mean? Co, con, com. Combine. Co, that's right, together. So this word is just the original Latin that produced these. So together. So again, we'll do a timeline. And you could either think of it like this, two things happening at the same time, A and B. They might just happen like that, or they might happen over a period of time. And when we do some social science survey or whatever, medical survey, we see that these two things seem to occur together. Ah, well, because they're together, that must mean that A causes B. Not necessarily. We can have things that occur together that are not necessarily caused, don't we? Things where there is a cause, sure, they'll go together. But other things can occur together that are not necessarily caused by each other. So therefore, A equals B will A cause B. That's the problem, not necessarily. When we see things that happen together, we call it correlation. There's the co again. Co together. Correlation, two things go together. Right? Like, for example, an easy one.
Smokers take the fire.
Well, smokers and lung cancer.
Yeah.
Yeah. So over years we've tracked a lot of smokers. Over years we've tracked lung cancer rates. There's quite a high correlation, isn't it? So we say high or low correlation. High, low, or even you can get negative correlations between things. So now in that case, there's been other evidence to indicate that the two things are happening together. Sorry, there's evidence that one does cause the other, isn't it? But it's extra evidence from outside. It's evidence of further testing. What are the key methods of determining research? Yeah, studying cancer cells, determining the chemicals within tobacco smoke, the 500 different chemicals or whatever, isolating a number of them as carcinogens, chemicals that cause cancer, whatever. There's all that extra evidence. So, but correlation alone is not so. Here's the key to the Cum-Hoc thing. The correlation does not necessarily mean cause.
Cigarette manufacturers.
That's true, sure. There's a huge debate, isn't there? The manufacturer will try to produce evidence, and there's a very good book called Merchants of Doubt by Professor Naomi Oreskes, who's a professor of the philosophy of science. And she looked at how tobacco companies tried to produce evidence through the 50s and 60s as there was more and more mainstream medical evidence emerging about this connection and the causal nature. And they paid scientists to find alternate evidence. And they got public relations companies, actually, not just science. They got public relations companies in. And their main method was, don't try to disprove the link, just try to make it doubtful that there's the link. That's an easier task. And that's why the book is called Merchants of Doubt, because that's what the PR people said to the tobacco company. Don't worry about disproving it, just create collocation, an element of doubt, so people aren't sure. And that will mean maybe the scientific evidence develops and gets overwhelming, which it now has, but if you keep that doubt going and you keep injecting through media campaigns and advertising or whatever, you might get another 20, 30, 40 years of being able to sell cigarettes. It might eventually, the evidence eventually may catch up with you, but you'll get several $billion with more decades of cigarette sales. Now the interesting thing about this is, because it relates to another important issue now, those very same public relations companies, exactly the same ones that did that work for tobacco companies, are now doing that work in the area of climate change. And they are working for the energy companies, fossil fuel, coal, gas, etc. And they're pursuing exactly the same strategy. Let's just create in the community doubt as to whether climate change is happening. Not necessarily disproof, but just evidence sufficient and arguments that we create doubt. And if we do that, we'll create this false debate. And if you look at the public statistics on it, and especially in America, there are quite large numbers of people who don't believe that climate change is really happening, even though 97% of climate scientists do. The public relations groups have done a very good job, advised by these characters, same people who advised the tobacco companies 4 decades ago. So, there's all sorts of, and as critical thinkers, my point is we need these kind of things. Remember that macro-micro thing? These are important for the micro-argument, analysing the micro-argument, but a macro understanding of how society works and who's trying to trick you and who's got power and probably going to try to trick you more through media and through think tanks and public relations machines, that's real criticality. In other words, going into the micro and getting these tools, really important. But the macro stuff is equally important. You'll find a link, if you want to pursue that. I'll write up the title, because it's on the Moodle. It's in the critical thinking section. And the whole climate change area, of course, think of this sort of thing. Correlations. Rising temperatures and other effects. Not necessarily cause, but we have to look at further evidence to see if it's correlated or not. Now, if we take smoking and cancer, it seems obvious to now, after all scientific evidence, that there's some sort of causal connection. But let's take another one. What if we found that, well, there is actually at the moment, last few years in Australia, there's a baby boom. More women are having babies. So if we put that on a graph from 2000 to 2015 there, imagine we saw this. It's going up.
7,000 for each baby.
Well, that might be a factor in why it's having up. Not sure.
Yeah.
Imagine that. Okay, now imagine we went to the central market and we said, okay, have you got data on your vegetable sales? Sure. And they found that watermelon sales went like that. Ah, well, it's clear, isn't it? These two things are both going up together. Therefore, it's the watermelon. It's eating more watermelon that's causing more women to have babies. What? Look, they're working together, aren't they? Ladies, don't eat any more watermelon unless you're really serious about more kids. Unless you want to stir more curry. Don't eat watermelon. Now, we naturally laugh at that because it's sort of ridiculous, isn't it? Because those two topics are really far apart and we can see the unlikeliness of them actually being related. But when we get other things that, smoking, lung cancer, etc., sure, they're closer in topic and therefore we more immediately believe it. But, we still, just because it's in the same area doesn't necessarily mean it's connected, does it? There's a very nice website, I'll get it up in a minute, that demonstrates this kind of thing. And it's based on real data. It's quite kind of funny. Just to give you a few more examples. So this is the point. The correlation, we had a correlation between watermelon and the rise of baby deliveries.
But if they find out watermelon inside can produce something for the
Yeah.
woman, then
Yeah.
that different stories.
That's right.
Okay.
Because, and that could be a scientific advance, isn't it? There really might be. I mean, we laugh because it doesn't fit our models of the world, but in fact there could be,
Yeah, some
according to
chemicals.
ancient Chinese tradition. Right? There is something in the watermelon
Yeah.
that if you want a big and happy family, you eat lots of watermelon. Maybe they're right after all. So we have to be careful at two things. That's a good point. We have to be careful at just embracing the idea, and we have to be careful about dismissing it too, because there could really be something there. The
Because
only
lots
way,
of people say when they do things like that, they always show the evidence. What is in the watermelon?
Yeah, they could be wrong, but they can say it in the way that it looks like, they can say it could be false, and they can say like, they weren't sure like from the woman who ate watermelon for this period of time, showed that they have much healthier baby in case, and that they can show it like there, but
that's right. You'd have to do other tests and other studies, wouldn't you? They might get a bunch of women, 100 women eating watermelon.
well, this period of time
others
showed
not
this
eating
much
it.
improvement.
Yeah, and we look at hormonal levels
Yeah.
and fertility levels and ovulation, and there might be a significant difference. And we weren't expecting it at all, but that correlation gave us a kind of little flag. Oh, maybe there's something going on here. But the point is, it's a maybe, isn't it? Correlations are very useful for starting off research, because we see, there might be a causal connection here. Might. Then we dig into it. We do that experiment. We find nothing, or we find something. That's certainly scientific
Now, what I'm
progress.
saying, if they do it, there's fallacy in there. So how would we know that it's not?
If they do what?
Suppose they write an article on this same topic,
Yeah.
this some journal, they write an article on the topic similar to this, and it's false, but the language that they use or the statistics that they use seems real. How can we find out this false article is not real?
So
That's the thing.
if the
If the
article
research is original or no, it's
Yeah.
just made up research.
yeah,
That's the thing.
all right. It's getting harder.
Yeah,
There are lots of websites out there that kind of purposely, for the purpose of fun,
yeah.
write articles that
Because
are not true, and
the
they make
statistic would, like if you see it in an article, statistic based, everything
Yeah.
based, but you don't know if it's made up article, made up data, or it's like real experiment.
That's right. So I think that's one thing. Logos, ethos, pathos, ethos. Where's that data coming from? Okay, if it's coming from probably Adelaide Uni, Flinders Uni, Harvard Uni, you'd sort of say, okay, well, it's probably, but we can't say absolutely. So that would enter your calculation to some degree, but it's not the only thing. And this is, okay, we're going to get onto it today, referencing. At the end of that article, there should be a whole lot of references. So can we chase where that data actually came from, who gathered it, and remember that bias sample stuff we did, how good was the method of data collection? Was it double blind, randomised, or was there some kind of possible bias in it, etc.? I think chasing sources is a really important thing, and then checking the sources against, and that can go on and on and on, can't it? That can be an infinite process. You get to another article and that's got references and you need to check that. But sometimes that's how far we have to go. Yeah. Okay, let's, I'll get that thing up on the computer in a minute. Let's just turn over your conversation page there. And have a look at I won't even read them out because they're kind of obvious once you read them out, but I'll let you have a discussion about them. Number 18, number 19, number 22.
Number 19 is done.
Did we do number 18?
We have done number 19.
No.
19.
Oh, sorry, not 19. 18, 20, 22. All right, look.
And then Friday
have a look at those ones. Number 18, number 20, number 22, and have a chat. What fallacies do you think are being committed there?